Main objectives is to define virtualization and describe it. Purpose, list the requirements needed to set up and use virtualization, describe how to use client-side virtualization, and identify potential pitfalls with it. One of you is still typing there. Have to put mute. Oh, fine. Okay. How would you explain virtualization to a client?
Can we say like VR?
I would say like
Access.
it's just like a different reality.
In simplest terms, it would be running a program that's not meant for your computer on your computer.
I can run Windows, a virtual machine, or that's basically Windows, and I'm on Windows. I can also do one for an application, right? What else can I do? I can put, Linux, right? I think that's what Jordan was alluding to. It doesn't matter really if it's the same one. Sometimes you can create virtualization just to be able to create what they say a sandbox to see and test how a virus works without it actually infecting the actual host or the server itself. So client virtualization is in two different ways. Does anybody know the two different ways, more or less, that it comes?
You mean a hypervisor 1 and 2?
Correct. Do you know the variance between 1 and 2?
Yeah, number 1 is considered headless, and then number 2 requires an operating system upon operating system. In other words, you're running the operating system, so you can run a program to use the hypervisor, which is referred to as number 2.
Correct. So in layman's terms, the way that they try to make it easy is for people is that number 1 is bare bones. Basically, it is the actual server itself who gives the possibility to create endless environment of virtual machines. Key word I keep on using is virtual machine or appliance, because virtual machines can be routers, can be computers, can be servers, can be firewalls. It's a virtual environment. So basically, on the bare bones unit, I do not need an operating system. It itself is the, technically, lack of a better word, the OS. It gives you a front end to create all the virtual environments that you want and be able to obviously function that way. The other one is when you have it inside, let's say, a Windows server. So now you have a Windows server who's actually now has another application. You have various ones. Windows has their own. They also have the one that we will be using later half of all of this is the Oracle one. Anybody know what's the name of the Oracle virtual machine? That would be VirtualBox. So here's your virtualization overview. So compared to one to the other, from what I said, can somebody understand which one is which looking at this interpretation? Which one's 1 and which one's 2? Which one's bare bones and which one has an application before or some type of virtualization before? What happened? Which one's 1, which one's 2?
Number 1 is the second one, and number 2 is actually number 1.
Okay. So number 1 is number 2, and number 2 is really number 1, if I understood you.
Yes.
I take that. Yes, that's correct. Let's try to get this a little bit easier. A, for lack of another thing, is really number 2. And B is really number 1. Does everybody understand what's going on?
What are the names of 1 and 2 again? Or what do they describe?
Well, I'll show you here. I believe it's going to get into the details of it. But basically, no, it doesn't have it here. Sorry, it's coming into the details. What happens is, in the bare bones, on 1, I do not have anything like Windows Server, Linux, nothing's on there. It's bare bones front end, so that I have a front end, or in this case, virtualization layer of where I can put whatever appliance I want to create on this server. So there's no way that a person with Windows that gets on the network is going to go and authenticate to this appliance. Doesn't have Windows installed. Doesn't have any OS on it. What it has is its own type of OS, which is the virtualization layer. There, it has a GUI that allows you to create various appliances. On there, it creates those containers where then you can put your OSs, or if it's a firewall, or if it's a router, if it's a switch, whatever you're putting in these little containers, those are the virtual appliances that will be housed in there. Versus you get a Windows server who then will then create the actual information. Let's see. While workstations can run multiple operating systems, they cannot run them at the same time. With virtualization, the same workstation can run many different OS simultaneously, virtual machines. This saves hardware costs and needing to have access to different operating systems for many reasons, including testing software, different platforms, working support, and developing new code, as I stated. The hypervisor. That's the actual application that allows you to be able to create virtual machines. It's also known as a virtual machine manager. The hypervisor software has multiple operating systems sharing one resource or one host. It also manages physical resource allocations for all VMs. So we need to be very careful, since it is going to be adding more virtual environment. Every operating system requires so much, right? So every appliance needs so many gigabytes of space, or so much of RAM, or so much in processing power. So we need to make sure that the appliance can actually, that the actual hypervisor, whoever we're using, can actually host virtual machines. As we stated, there was type 1 and type 2. Type 1. Jordan, if you can just help me out here and read just type 1.
Type 1, known as bare metal or native, works directly on the hardware of the host and can monitor OSs that run above the hypervisor. It's basically the OS for the physical machine. The purpose is sharing and managing hardware resources between different OSs. Type 1 is faster and more secure than Type 2. Examples: MS Hyper-V and Citrix/Xen server.
Thank you. Questions on the bare bone or bare metal native mode?
When it says
Can you
OS
explain?
is the
So the
Oh, you go
OS is
ahead.
the physical one. On the OS, as I stated, the hypervisor, just as we, let me see, I think I have virtual machine here. I'll show you what I mean by it. I believe I have.
are OSs that run above the hypervisor the virtual OSs?
Virtual box, I think is the one that I have. I guess I don't have it. Well, at least we have. See. That's not going to show it. Right. This is the actual hypervisor itself. You'll see that it has a list of different appliances. So in this case, VirtualBox is running on top of Windows. So Windows or Linux or whatever, it has this extra OS, or sorry, this application here to be able to house it. All of these have their own operating system installed. So you have Windows running VirtualBox, who then that hypervisor, VirtualBox is the hypervisor. You can create whatever you want, whatever machine you want. Versus you have the Microsoft server ones, which when you turn them on, all they have is that OS or that hypervisor screen for you to create machines. You can't use it as a proxy server itself without creating a virtual environment. Bare bone metal, this machine can do nothing except for create virtual machines. This virtual machine manager can only do that. You can't connect to it. You can't do any of that stuff. Like if you were connecting to a file server, print server, no, it's not that. Now, it's virtual machines inside of it that you create, yes. They all then share the resources of this bare metal server. This is obviously going to be a server who has server blades. It has a whole bunch of hard drives, processors, something that can actually do this. It's not going to be your computer. You're not going to go and have that like that. It doesn't come that way. These come that way. Now the type 2, which is also known as the client-side virtualization, this one is, as I stated, is actually an OS that's installed basically on, and then on top of the OS, you put the hypervisor or the VM, the virtual manager, virtual machine manager. Now, any OS that's inside of it is called a guest OS. So if I have a virtual machine who's running Server 2008, that's the guest OS operating system. Versus the host OS might have been Windows or Linux, which is the original one, the one that I boot up with, my computer. Any questions? So you have your hardware here, you have your hypervisor here, then you have your guest OS 1 and 2. So those are the two machines, right? And the applications inside those two machines. Versus you have your hardware here, you have Windows Server turned on here. Now you install the hypervisor. Now you create your OSs here, and then you can have your application. Any questions? Does it make sense now?
So, okay, does Mac and Linux computers, do they also have a
VirtualBox, I believe, can get installed on Mac and on Linux machines. Now, can you create
that's a hypervisor.
Yeah, that's a hypervisor.
VirtualBox is a hypervisor.
Yeah,
the host OS
would be Apple here, and then this here would be the VirtualBox. So the Apple OS, right? The Mac OS, sorry. Mac OS would be here, and then I would install the hypervisor here, and then whatever inside the virtual machines that I create inside this virtual manager, I can then install whatever operating system I want.
And then type 1 is specifically a server that doesn't exactly have the host
Here's
OS.
the server. It has this hypervisor. The same screen that you see here is at this point here. There's no ifs, ands, or buts about me logging in to Windows or me logging in to Mac OS or Linux, nothing. Straight in here. I turn it on, it's here. That makes sense?
Yep.
All right. Continue with playing with this here. Who can help me with this slide?
I'll do it. Client-side virtualization requirements. Running multiple OSs on one physical workstation will require more resources than running a single OS. For performance reasons, the workstation used for virtualization should be well equipped, specifically in type 2, which divide resources between the host OS and each VM OS. The primary resources are CPU, RAM, hard drive, and network performance.
Thank you. Any questions? Doubts? Thank you. Next one. Who's a brave soul?
I
DeAndre.
can do it. Oh, no.
DeAndre? Help me. All right, go ahead, Lázaro. We lost. I think you might have touched BRB.
Maybe get disconnected. All right. Client-side virtualization requirement. Running multiple OSs on one physical workstation will require more resource than running a single OS. For performance reasons, the workstation used for virtualization should be well equipped, specifically in Type 2, which divides resources between the host OS and each VM OS. The primary resources. Oh wait, I'm reading the wrong one.
I was wondering where you were. I'm not sure where you were.
It's that I'm used to it
Here,
calling.
there.
Hold on. Wrong one. Requirements, hardware resources. CPU. A multi-core processor is recommended since the hypervisor can treat each core of a processor as a separate virtual processor, and it can even create multiple virtual processes out of a single core. Some hypervisors require the CPU to be specifically designed to support virtualization, Intel DT and AMD V. In most cases, it must be enabled in the BIOS before the hypervisor will install. Memory is always a major concern with using virtual instances. The hypervisor allocates the existing RAM between the host OS and each VM. However, each OS installed needs to have at least minimum RAM requirements in order to run the VM. If the host OS requires 4 gigabits of RAM and the guest OS requires 2 gigabits of RAM, then you would need a minimum of 6 gigabytes of RAM. Recommendations for installing hypervisor and VMs include a hardware-assisted virtualization and 16 gigabytes of free storage space for each instance.
Okay. Can somebody tell me what can go wrong here from these requirements that they're telling us? What can happen if, here?
I see 3 issues. One, the possibility of experiencing a blue screen is probably very high. 2, is going to run extremely slow. And 3, you're going to get probably errors and artifacting as well.
And so this appliance that you decide to do things with, you got to be fully aware. There's one other major issue that you have also is the OS that you're installing it on, right? So let's think about this real quick. Does anybody remember what's the maximum a 32-bit operating system
4
recognizes?
gigabits. 4 gigabytes.
So what happens if I go and install a virtual machine on a 32-bit operating system?
Better hope it's a Linux and it doesn't require more gigs than it should.
It's not. It's going to crash, basically, right? It's going to crash. You guys got to be fully aware if the OS is not able to recognize the extra amount, right? Let's say if I had 32 gigs inside that motherboard because the motherboard is recognizing it, but my OS is only recognizing 4 gigs of RAM, it's not going to work. That's a major problem. You have to be fully aware of what's the operating system you're using, what's the capability of that operating system, and what's the capability of my physical machine. How much do I have? Also, the free space inside your hard drive, because you're going to be actually creating virtual hard drives as resources for these machines. Everything is basically being created, including how much resources of processor or memory. You actually create how much memory is installed in that computer, that virtual appliance. Next slide, please. That would be 12 for those who, never mind. So, enabling virtualization. As I stated, also the motherboard needs to be able to do this. If you try to do this in a machine that's incapable of doing it because the processor and the motherboard is incapable of it, you will crash and burn or go very, 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 I could do that forever, slow. Come into the BIOS usually when you boot up the machines. Everybody remembers how to get into a BIOS. You usually every manufacturer has a specific key. It will tell you when it's being turned on. It's either delete, F12, F11, F1. It all depends on the actual manufacturer, but you'll see it when you're coming up and it's booting. Sometimes it flashes real quick. You come into the BIOS, go into the advanced settings, and you'll see the Intel virtualization technology. You can enable or disable that feature. Then your computer will be obviously available to do it. Your processor, that part of the brain will be obviously activated to know how to run the virtual environment. Next slide, please. Brave souls. We had Teresa just, who's next?
I'll go.
Thank you.
Requirements network. Each VM instance can have its own IP address on the local network so it can communicate on the network. The VM will create a virtual NIC and manage the resources of that NIC appropriately. The virtual NIC doesn't have to be connected to the physical NIC. An entire virtual network within the workstation can be created.
Yeah. So you can see here, down here is the NIC card. That's the physical NIC card of the actual host. So what he does, he creates a virtual network, which they all have IPs. At this point, he is basically, that you can say is the point where it bridges into the real world. So you could actually create a virtual network and disconnect this cable here and create what they call a sandbox so that they can't get out of here. There's no bridge connection between the virtual network and a bridge connection to the physical NIC card. That's how they do what they call sandboxing. So in the virtual appliance itself, you could either attach it to the NIC card with a bridge, virtual bridge, or you could just leave it completely without it being able to get out of the router. Lack of a better name. Your NIC card now is like your WIC or your WAN interface at that point for this virtual environment. All these virtual appliances, you can actually make it so that they can see each other if you make them all in the same network. As long as they're in the exact same virtual network, they will be able to talk to each other. Once again, unless if I turn on this segment here or node to be able to get out, they're not going to be able to get out. Justin, help me out here with this slide, please.
Of course. Requirements network. Every hypervisor has its own way to set up virtual switches to create virtual networks. Virtual networks can be configured in two ways. Internal networking allow all VMs to connect to each other through their VNIC, but not with the outside. Bridge networking allows the virtual network to access the same resources than the real network, including the internet.
Thank you. Here's a physical server, as I stated, and also to Justin right now. Here are my virtual machines that I created inside the hypervisor. Here are the virtual NICs that it has. Here's my virtual appliance here. Here it is right here. That's the virtual switch now that I have connected all these guys into this virtual switch in their own little network. Now that I give it a bridge connection to my physical NIC, which is connected by Cat5 or Cat6 or 7, depending what you have, to the actual physical switch in the real world. Any questions?
I have a question.
Mhm.
When you have multiple VNICs and then virtual switches and will go out, when they go outside the physical NIC, is that do they share that IP like NAT, or is it their own individual IP?
These are all private IP addresses, right? These are all private IP addresses in here. This is a LAN. We agree? So now that
Yeah.
this is one LAN, right?
The
We can-
virtual LAN though, right?
This is a virtual LAN, yeah, but it's still it's for computer purposes. It is a LAN. They don't know the difference between the physical world and the virtual world, right? So now here goes a network, and it has its information. If I didn't have an internet connection, let's pretend this was just a regular office, and this is an other office over here, right? And I'm bridging from one side to the other. Do you agree, basically, that they are basically routing out through this connection? So on this side, it's still a private network. And then there's a router who gets them out into the internet. So what happens is, just like in any bridge connection, he NATs all of your information out to the real world. Then when it comes back, he NATs it back to the correct appliance. He becomes, he does the function of NATing. He's not routing, not making routing decisions, he's just NATing. The major difference. Routing has NATing in it, but it also makes decisions based on routing tables. This has no routing table, only NAT.
Okay, so that makes sense. So they all have their own private IPs, and then when they want to go to your physical network, they're gonna then use their own version of a public ID, basically, for your physical
Not
network.
public, it's still private. Still private.
It's all private.
Yeah. Here's my,
So wait,
here's my server, right? Here's my server. It's connected to the LAN. It's connected to a real LAN. This is a LAN, not the internet.
so they're not using NAT.
Yes, they are.
What?
Why is NAT only used for the internet? Who is NAT only? There's a proxy server who uses NAT, and he's using two IP addresses that are basically going in. So it's not, NAT function is only to translate one IP to the other to be able to communicate from two different networks. That's all it does. Keeps track of that information. So here is then the router. He connects out to the internet. So this could probably be, let's say, a 192 address. This might be a 10 dot something address. And then out here, you probably have a 28 dot something address. So what he does is he NATs this 192 address, and he assigns you a specific port, and he replaces it with his IP, the 10 dot something IP. Then he sends the packet forward. Wherever it goes, be that it stays inside the LAN or if it goes out to the internet, when it comes back to this IP, to that specific port that you stated you're in, I then NAT it back and give it to you. I can care less what happened when it get out the port. As long as it comes back to me, I'm giving it back to you. It has nothing to do with the internet at that point. It's only NATing from one subnet to the other, from the virtual subnet here to the actual LAN, the physical LAN that I'm connecting to. It's a bridge connection only. Remember, we did that also with our phones, right? When you did that in your phone, you really didn't go directly from your iPad to the internet. You went from your iPad to the phone, and then the phone natted you out to the internet. Came back, gave you the information. Same thing is happening here. You get to this device here, but then that device sends it on forward for you. That's all he's doing. Did it make sense? Yes or no?
Kinda.
Want a nicer picture?
Maybe that would help because I'm kind of confused. It's like, yeah, I know he's using NAT. The part I get confused is that when it's leaving the physical NIC, I thought that it's supposed to use NAT, right?
Yeah, but NAT is only network address translation. It only translates from one IP to the other. That's all it does. Doesn't
So is it doing
take
it?
it to the internet. It only translates one IP to the other. That's all it does.
So it's not doing
Correct.
that?
I'm sorry?
So it's not doing that.
It is doing that. NAT is that. That is NAT.
I'm sorry, I'm confused because I'm like, yes, I know it's doing NAT when it gets to the physical NIC, the physical NIC, because it needs to communicate with the other computers within the LAN, right? So it's converting its IP, the virtual machine's IP, to then the actual host of the computer, the physical part, right?
This is his IP, 192.1.1.1. That's the virtual machine's IP. Okay? The real server's machine is that one there. It's 10.1.1.1. So if I want to get out, I want to get out of here, and I want to go into whatever resources, be a server, a print server, another host here. I want to get into a file server that's over here inside the real world. That's my intranet, still inside my network, private IP network. He's only going to NAT to here. After that, the router, if you're going to go out to the real world, will NAT you one more time using the server IP here. He's going to then grab that IP and he's going to replace it with his IP. That's another time that it gets NAT. That's between the router here and the real world. So when it comes back from the real world, he NATs it, gives it back to this IP with whatever port that originally IP came with. He gives it back to this guy, and then he replaces with the port that you gave him to that IP. He NATs it back. If you go out to the internet. Otherwise, there's only one time that it gets NATed if it stays inside the physical internal network.
Okay, I think I get it.
Anyone else have questions or doubts? Okay. You remember the function of a bridge, right?
Yeah, it's to connect to different media.
And the bridge, to do that, it must be able to NAT your information. It's not a router. We agree a bridge is not a router. All he does, he NATs from one network to the other, the information.
Okay, so I think I get it now. So the virtual machine has its own virtual, and basically when it's trying to get out, it's just NATing its IP to the actual physical NIC to get to whatever it needs within the network. And by chance, if it wants to go to the internet, the router has to NAT it again. And then when it comes back, it goes through the step. Okay, this goes to this physical NIC,
Yeah.
which is the bridge. And then it goes to the virtual machine because, hey, the physical
Yeah.
NIC remembered, hey, this is for this virtual machine number 2 or whatever. And then it goes back there, right?
Exactly.
Okay, I think I get it. Thank you.
Not a problem. Who's our brave soul for the next slide? Pablo?
Primary security. All security concerns that affect individual computers also apply to VMs. VMs are vulnerable to hackers and malware just like the host machines. If the VM has access to the internet, it must be protected, isolated, and have permissions secured for files the VM holds. You must ensure the guest OS and antivirus programs are kept up to date.
Yeah, very, very dangerous environment that we live in is that sometimes in the IT world, they forget they have these guest OS out there who are vulnerable, and then they don't send updates or make sure that the updates are happening. So even though it's a virtual machine, if it has connection to the internet and a hacker has the right payload, and that virtual machine happens to download it, and he gets a backdoor in, then obviously not only does he have access to there, he can obviously then most likely come out. Because if you got a connection in, he'll be able then to somehow get out and look for his way out throughout the whole virtual environment or even the actual host. Next slide, brave souls. Christina.
Requirements, emulator. An emulator runs one type of program on a platform that is different. For example, emulators can be used if you want to run an Android-based game on a Windows PC. This method is slow and causes resources to bog down, so running a VM with a specified OS works better. Although emulator and hypervisor have been used, the hypervisor emulates hardware and presents this virtual hardware to each VM. The hypervisor also supports multiple OS, while an emulator appears to work as one specific OS. The only requirement of the emulator is that it is compatible with the host OS.
Thank you. You guys understand the variance between an emulator and a virtual machine?
Mostly. So basically what it's doing, the emulator is just a program that's trying to mimic the hardware, but that's on the OS side. And it's only a program. Is that correct?
I'm sorry, it was breaking up on my side over here. Can you repeat? I do apologize.
Yeah. So the difference from an emulator and a virtual machine is that an emulator is something that tries to mimic a hardware, but on the software side, and it's only for a very specific program.
The emulator tries to emulate another OS. In other words, it's locked down with that. There's nothing else that I can do with that. One of those that you guys have probably seen are the emulators of the old Nintendos. You've seen that they even come and they look like the old Nintendo box, but it's got like 500 games installed on it. That's an emulator. There's nothing else that I can do with it except for its purpose. It basically mimics any other operating system that you want, but you can't go like in a virtual appliance or a virtual machine. I can actually get rid of that resource itself, create another virtual machine, and install another operating system. Or that same virtual machine, I can actually blow it out and put another operating system on it. Here, the emulator, that's what it is. A lot of people do that for their actual computers. They install software, obviously this emulator, that then mimics an Android phone, and now they can play all the applications that they have on their Android device. They can actually do it inside their computer, bigger screen, and obviously still play the same games. Just emulates or mimics the other operating system. That kind of help or no? No? Yes? Maybe? So. Next one. VDI.
You stepped away for a second.
No problem. Who can help me with VDI?
VDI virtual desktop infrastructure refers to the process of running a user desktop inside a virtual machine that lives on a server, usually in a data center. It's a powerful form of desktop virtualization because it enables fully personalized desktops for each user with all the security and simplicity of centralized management. VD
Okay. I'm back. You guys still here? Hello? Hello?
Right. Virtual desktop infrastructure refers to the process of running a user desktop inside a virtual machine that lives on a server, usually in a data center. It is a powerful form of desktop virtualization because it enables fully personalized desktop from each user with all the security and simplicity of centralized management. VDI enables customers the mobility and freedom to access virtual desktops at any time from anywhere or on any device. Traditional PC, thin client, or even a mobile device. This is a server-based virtualization.
Thank you. Any questions on the VDI or the virtual desktop infrastructure?
Wait, is there a simpler description of this? I kind of get it, but like also I don't.
Think of it like this. You have a server and it's running all your computers and it's remotely outputting that virtual machine to a computer. So imagine you have a monitor and keyboard and it's has a huge connection to one computer and you're just using the computer as if it's like a normal computer.
Is the purpose of this is let's say I have XYZ application, right? Now, if I have XYZ application and sometimes there's a lot of remote sites or depending people who change from here to there, their job roles change, or maybe they just, their PC goes down and we want to make sure this critical application is never down, right? So what they'll do is that this server will host that virtual infrastructure. So when everybody logs on to that server or that virtual environment, they have an application and everything installed in there. Your actual documents, everything is in there. You don't lose it. In one central location. Now it doesn't matter. I can get a rinky-dink computer that, well, not a rinky-dink, but I can get a computer that it doesn't matter where you are, when you are, as long as you can come into this virtual environment, connect to it, you'll be able to obviously use it.
So essentially just a virtual server.
Exactly.
Okay.
Virtual desktop server, yes.
All right, understood.
All right. Next slide.
Using client
Mm-hmm.
using client-side virtualization. General steps to follow when using client-side virtualization. 1, determine client's needs for virtualization. 2, evaluate the computer to ensure that it can support the VM, CPU, the RAM, free hard drive space, network connection. And then number 3, hypervisor to use, security requirements for number 4, and number 5, install the hypervisor and the guest OS.
Thank you. Pretty simple, direct. Any questions? Next slide. So installing VM, this is a little homework that we have for the team. We're going to be downloading Oracle VM. You have until, as I stated before, whenever this came up, you have, I believe, until the 5th week, which I think is next week, if I'm correct. The end of next week to install it on your computer. Each team decides who is knowledgeable enough to try to help them. Yeah, I think it's pretty simple. You just look for Oracle VM VirtualBox. download and install on your computer. From there, we will then have eventually some sessions on creating hyper machines and everything. But before then, please install VirtualBox from Oracle on your computers at home.
Diego.
Yep.
I already have multiple VMs. Should I, use them or just start from scratch?
In class, we will be just creating new ones. As long as you have the software installed, you don't have to delete any of your virtual machines. That's not a problem. But for the purposes in the class, we will be creating hypervisors and everything at one point. Installing virtual machines inside of hypervisor. So basically, just go into the Oracle, into the GUI. You click on New. It gives you a little GUI that walks you step by step. You can select the type of OS and or machine that you're creating. You basically name it. Then you come in and you set the actual RAM on the hard drive, your CPU cores, everything. Set it up here, how much you want to use. Obviously, it even gives you a little gauge there, letting you know how far you can and cannot go with this. Gives you a little warning there. Another good thing to do, and this is obviously in reference to the CPU and everything, when you're dealing with the hard drive part, go ahead and let it be that it's not fixed. You want to make sure that it grows. You want to set a maximum of growth, but you don't want the fixed set. You want it to be the one that's actually automatically grows. Also, you get to set all the different features, including here, as you see, the network. So you can include the USBs if you want the USBs to come across, or anything that's on your physical machine to be able for it to use. Audio, all that gets configured. Eventually, then, we will be starting the actual machines and booting it up and installing OS. Our pitfalls, someone can help me here?
Pitfalls of virtualizing. Challenge. Setting up the environment is no different from installing a clean version of Windows. It can have many different installation issues, just like the host would. Solution. Following the steps for installing and reinstalling when needed will resolve most installation issues. Challenge. Another issue to using VT is that it uses the same system resources as the host. Solution. Ensuring the system has enough RAM and CPU that can handle the VM or multiple VMs will allow the host to run smoothly. Challenge. Security concerns. Secure permissions, firewall, and malware secure location. The solution to most virtualization threats is to always apply the most recent patches and keep the system up to date.
Thank you. Any questions on the pitfalls of virtualization? Next slide, please. Don't worry about that slide. And let's go to the exit. As I stated, we're going to have, I believe it's next week, a lab. If it wasn't built in for this week, we're going to have sufficient time to create virtual machines. It's not in the 1001. I know for sure in 1002, we're creating virtual machines and different operating systems there that you can test out. Feel free to download it at any time, play with it if you feel like it, and try to figure out how to use it. It's up to you. We will be obviously eventually doing it in class and ensuring that we all understand, at least with Windows 95. I think not Windows 95. Well, I think it was Windows 7 or 8 that they gave me. All right. So number one.
I'll do it.
Okay.
Which of the following are requirements and recommendations for installing a hypervisor and VMS? hardware-assisted virtualization.
Hardware assisted virtualization. You said A?
Yeah.
Is there any other one?
Oh, you can choose more
E?
than.
B.
D?
B, yeah.
Oh, so it's all of them. Okay.
I say
Delta, yeah.
B.
Delta. So it's make
Delta?
sure that the hardware can do it. I don't know what each virtual machine needs. 2 gig could be wrong. Some operating system require 4 gigs. I don't know how much each virtual machine needs specifically. Let me rephrase that. I know for sure that every single virtual machine will not require 2 gigs. I know that for sure. So that's not the right answer. So the only other one there would be 15 gigs free in your hard drive space for each virtual machine to be able to install OS at minimum, right? And there's no such thing as a virtual network driver that I'm aware of. Next question. Number 2. Vas con dos dedos. Alexa. Number 2.
Using a client-side virtualization, how many operating systems can be running on your computer at the same time, or at zone time? Never mind. D.
I agree.
Which one? Delta? You said? Or
Yeah, I said.
okay, yeah, it's limited by available resources. So we can't say currently by a given number at this point because it's not telling anything to us. So the only right answer there, yes, is D. We would need to know exactly what are the resources that it currently has to be able to determine the amount. Number 3. Mohammed.
Right. So VMs running under a type 1 hypervisor are isolated from each other. It's a true.
Everyone agree?
I agree.
Awesome. Next question. Teresa?
Which of the following is a typical use of a type 2 hypervisor? I think it is A and B.
I
Everyone
agree.
agree? Yeah, so as we stated, I can create sandboxes for developers to test applications or to test and see how viruses react to certain things. And I can create honeypots to create as a lure to hackers. So I can create a actual duplicate of a given server, let's say a web server that I have, and then I make it look like if it's the real server, but with dumb files, not real files, not vital files of the organization, so that when they get in there, they think that they actually got information and it didn't. That's what a honeypot is. Questions? Number 5. DeAndre.
My I'm gonna have to refresh my page. Hold on. And their pause acting weird.
Okay, I'll be reading the question while that's refreshing. Maybe you answer.
Yeah, I have the answer. I just don't remember. Like, that. You can do that. That can work too.
Which of the following is true of a type 1 hypervisor?
Oh, yeah, it's C.
Oh, C? Okay, yeah. C, bare metal hypervisor. Everyone agree?
Yes.
I agree.
All right. Good, good. It's pretty much the end of this presentation. Is there any questions or doubts before we conclude here on this
Got a
presentation?
quick question about number 3. Let's say if the hypervisor 2, it's still isolated from each other, correct?
Let me bring up question number 3 real quick. VMs running under type 2 are isolated from VM type 2 are isolated from each other.
Also, what exactly is it referring
No.
to when it says isolated from each other?
No. Type 2, remember, they're not isolated from each other. A type 1 is, because I'm creating a machine, but in this one, in the type 2 that I'm aware of, I can actually leak into another one. As long as I get into the first one, I should be able to get into any of the other ones because then I'm on the network.
So how do they keep themselves separated versus 1 and 2? I know that type 1 is that it acts like an operating system to virtualize it. And then number 2 is the OS that is now running the program for the virtual machine.
Correct. So you just said it right now. So that there's an OS that's involved. On the first one, there's technically Windows is not involved. Hypervisor is the OS. So every appliance is completely oblivious of each other unless if I tell it otherwise.
But on a hypervisor 2, because the operating system, in other words, Windows running it, that's why it's somewhat aware.
On the outside, I can attack.
But not on hypervisor 1, because the hypervisor 1 is literally just
Separating
running
each
the
one.
hardware separately, correct?
Yes.
Okay, I get it. So hypervisor 1 means it's literally running the
That's
hardware
why
for
it costs more, and that's why you would put an environment, a company. You wouldn't put that on a big company. You would put that in a little company that costs a lot of money.
Got it. Okay, I understand it better. Thank you.
All right, that's pretty much there.